experiment for finding the saturated voltage for uA741, that means operation amplifier. We will find the Vsat. Now you can see that this is the circuit for that operation amplifier uA741, and these are the pin numbers. You can see pin number 7 is connected to the VCC. Therefore I show you this is the 1 2 3 4 5 6 7 and connected to the plus 12 volt. You can see this is the plus 12 volt, it is connected to the plus 12 volt, and you can see that 4 is connected to the minus VCC, and then it is connected to the minus 12 volt. And then you can see that 2, here 2, this is the inverting terminal and 3 is the non-inverting terminal. We create a potential difference between 2 and 3 so that the non-inverting terminal will have a slightly higher potential, and we'll see the output. Whatever the output will get, that is the Vsat. And after increasing the difference, and then the output will not change, and that is the saturated voltage. Now you can see here 2 has been connected, 2 is there, will connect to the positive terminal, will connect to the negative terminal here, and the 3 will connect to the positive terminal. Already we have connected to the positive terminal of the regulated power supply, and then 2 will be connecting to the ground. 2 will be connected to the ground, that means it's zero potential, and the small potential difference will create between 2 and 3, and so that 3 will have a higher potential, and then we'll measure the potential at the output. You can see this is the 6 is the output, and therefore we'll measure the potential, and that is the Vsat, V saturated voltage. Now we will just switch on that, switch on this is the power supply, and this is the regulated power supply. This is the regulated power supply, and you can see this is 0 0, and then we'll just small potential will create. This is a 0.1 potential will create, and then we'll measure the output. You can see this is the multimeter, and we are measuring the output here. You can just, and then measuring the output, I'm putting into the negative. This is the zero potential. This is the black one is to the zero potential common, and then output I am measuring the 6, pin number 6, and then you can switch on that, and then you can give the DC voltage. You can see that you can see that the potential almost it is a constant, it is not changing, and I have increased to the potential also. You can see the 0.5, it is almost equal to 10 volt. You can see here is 9.78, 9.78. We can take approximately for a 10 volt that, and that is the way, one of the way you can, before the experiment you can find the Vsat for, or if it is given as Vsat already being given, it is fine. If it is not given, you can find in this way. The color code of resistance for a 4-band. Now here we have given a sequence of color. You have to remember that sequence: black, brown, red, orange. In that way I have shown in the table. You can remember the sequence up to white. You can remember the sequence, and then every color up to white, it is I have assigned a value, number, digit I have assigned, and in the next column is a multiplier, and that the last column is a tolerance. Tolerance is I have shown on the gold, silver, and none. I'll discuss this thing. Now let us consider here one resistance where color code, the first is orange and red, and the last is silver, and the first two color band will give you the one number. That means orange and orange, these two. You can see orange is assigned as 3. Orange is assigned as 3. Therefore, first two will give you the number 33. Therefore, I have written here 33. And the third one is the multiplier. Third code is the multiplier. Here third code is the rad. Therefore it is the multiplier. Therefore you can see here you can see rad is equal to multiplier is a 10 square. Therefore you can see we got orange. Due to orange you got 33, and due to red it will be multiplied by 10 square. Therefore third band is the multiplier. Therefore we got the value of 3.3 kilo ohm. And the last silver is the tolerance. That means variation. It can the accuracy of the resistance the manufacturer gives, what may be the accuracy. It can go for a higher than 3.3 by a 10%, or it can be lower than 3.3 kilo ohm by a 10%. Therefore this is the because of silver it is given as a 10, therefore it is a 10%. And that is in that way you can find a resistance by looking at the color code.